This is R.D. Sharma solution, class 12th. We are taking chapter 31, probability. Now this chapter can be different depending upon your edition of the book. So if it is 31, then we are doing the first exercise, 31.1. In probability, mostly the cards question are being asked. So before that, we need to understand what cards means. So if you don't know about the cards, let's understand it. So we call it as a deck of cards or simply cards. So this is the whole picture of the cards which you will find in a deck of cards. There are total 52 cards. So in all, in a deck of cards, there are 52 cards in all. Now how this 52 are constituted? So we can divide this whole cards into 4 different parts. So when we have the equal 4 parts, there will be 13, 13 and 13 and 13 different parts of cards. We call them as suites. From here to here, that is 13 and 13, 26 cards, they are black cards. Then the rest card remaining, which are again 26 cards, 13 and 13, 2 suites, these are again 26 cards and they will be red cards. So there will be 4 suites, 2 black, 2 red. So what do you see here? The first line which you see is a club of cards. That is from 1 till 13 cards. These 13 cards, the first suite is club. Now coming to the second line. In the second line, we have again from A to K. So whenever you see this symbol, these cards will be spade cards. Again 13 spade cards. So from A to K, there are 13 cards of second suite which is called spade. Now when you combine this club and spade, which are black, there are 26 cards. So this is how this one partition of black has commenced. Now coming to the second part, which is the red cards. The third line again from A to K, and the sign is of heart. That is why we call it as these 13 cards hearts. So this is the third type of suite and it is called as heart. So this is the heart. Now again we have 1 to 13 cards which are again red colored. But now the symbol has changed. The diagram which you see on it changed. This is a diamond diagram. That's why we call these 13 cards, red cards, as diamond. 13 diamond. So this is diamond. These are the 4 partition and 4 suites. So in all, heart and diamond, these are red cards, again will be 26. Club and spade will be 26. So 4 suites, club 13, spade 13, heart 13, diamond 13. Club and spade, black cards, combine them, they call black card. Then we have a red card. Heart and diamond are red cards. Now if you see a particular line of the cards, that is the 13 cards, they are from 1 to 13. But the number cards are only from 2 to 10. Normally we assume that it should be written as 1 to 13. But the first card is not called 1, it is called an ace. Ikka, an ace card. 2 to 10, these are numbered cards. And from 11 to 13, 11, 12, 13, 11 is a jack for all the suites, 12 is queen for all the suites, and 13 is king for all the suites. So for 13 cards in one suite, there will be 1 ace, there will be 2 to 10, that is 13 minus 4, 9 numbered cards, and 1 jack, 1 queen, and 1 king. So let me take an example. What kind of question can be asked? Now the question can be like this. In this 52 cards, now when you pick a single card or take out one card, what is the probability of getting a queen? So the probability of any experiment or event is number of favorable cases divided by number of total cases. So you can call it as number of favorable events and number of total events, but it should be the numbers only. So in all these 52 cards, you can pick one card. So total number of possibilities, total number of outcomes can be 52. So number of outcomes divided by total number of outcomes. Number of favorable outcomes divided by total number of outcomes. So total number of outcomes can be 52. Any of the card you can pick. But what is our favorable event? There are in all in these 52 cards, there are 4 queens. 1 queen in each suite. So favorable event is only 4. That is, from these 4 queen, 1 can be picked up. So the favorable is 5 and total number of outcomes are 52. 4 divided by 52 is 1 by 13, and this is the probability of getting a queen if 1 card is picked from the deck of 52 cards. In probability, mostly the questions are asked on cards or rolling a die. Now when you roll a die, what can happen? In a fair die is nothing but a cube. The cube has 6 faces and 1 face will come up. Whenever you roll a dice, 1 can come, 2 can come, that is 2 dots, 3 dots, 3 can come up, the face can come up, 4 can come up, 5 can come up with 5 dots, or the final 6 dots can come. 6 faces, 6 numbers can come. So the sample space, the possibility is 1 can come, 2 can come, 3 can come, 4 can come, 5 can come, or 6 can come. Because there are only 6 faces, 1 to 6, only this can come. This is called the sample space. 7 can never come because there is no 7 here. It's an impossible event. Now this is about the 1 die, but mostly questions are asked about rolling 2 dice together. So the sample space will be what? So I'll give you a hint about this sample space. So these are independent events. That is, one is not dependent on another. The 1 die can give you from 1 to 6. The second die can also give you from 1 to 6. So in all, the sample space of first die will be 6. Second will also be 6. See, for 1 die the sample space will be 6. But when you are rolling and throwing 2 dice, 6 into 6 is total number of events. That is the total number of outcomes. 1 and 1. In first 1, then in second 2. In first 1, second 3. In first 1, second 4. In first 1, second 5. In first die 1, second die 6. Now this combination can go on. In first die 2, second 1, like this, 2 1, 2 2, 2 3, 2 4, 2 5, 2 6. Then 3 1, 3 2, 3 5, 3 3, 3 6, like this. Last one will be 6 6 accordingly. So there will be 36 possibility. So when 1 1 will come, they will add and we will call it as 2. First will 4 and second will give you 3, it will be 7. So what can be the question? I'll give you a hint. Now when you throw a die and you are being asked what is the probability of 4 coming? So total number of outcomes can be 1 to 6, that is 6. And what is your favorable outcome? You want 4. So it will be only 1. So 1 divided by 6 will be the probability of getting a 4 in single die. But in a die which we roll, there are number of 2 dice, then so just asking a question, 5 can come. Okay, so if 5 has to come, 2 and 3 will make 5, 4 and 1 can make 5, 3 2 1 5, like this can come. So total number of favorable cases are 4 and total number of cases are 36. So when we divide this will be 1 by 9. This is the probability. The first question is 10 cards numbered 1 through 10 are placed in a box, mixed up thoroughly, and then 1 card is drawn randomly. If it is known that the number on the drawn card is more than 3, what is the probability that it is an even number? 10 cards are there, 1 to 10. So we have to make the sample spaces of 2 different events. 1 to 10 can come. So the whole sample space will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Because there are 10 cards, 10 different outcomes can come. And it is thoroughly mixed. So there is no chance that 1 card can come again. Now 1 card is drawn randomly. Any 1 card can be picked up. Now if it is known or it is given, all these kind of phrases can lead you to a conditional probability. So in order to find out the conditional probability, we ought to apply a formula. So the second one is, it is known that the number is more than 3. So it can be 4 till 10. There is one more thing being asked. So if it is known or prior information is there that the drawn card is more than 3, what is the probability that it is an even number? So it is a conditional probability. We'll apply the conditional probability formula. So what are the events? Sample space is 1 to 10. But we have 2 separate events. And you have to judge the event according to the question, because if one thing has happened, what is the probability of the second thing happening? So one thing has happened, that is if it is known that the card on the drawn card is more than 3. So this will be our second event, B, 4 till 10, because it is more than 3 already given. What is the probability of A we need to find out? That is, it is an even number, but it is not known. See, even number can be any number from the sample space, but the B event is already known that the number is 3, greater than 3 or more than 3. So the A event will have all the even number. It's not that we have to choose from 4 to 10, because if it is known that it is greater than 3, that doesn't mean we have to choose only from 4 to 10. We have to choose from the sample space. So 2, 4, 6, 8, 10, all these numbers are the even numbers. So even number appears on the card is our A, first event. Second event is, which is known event, which is already known prior to finding out the second event probability, is the greater than 3 number has come or appear in the card. So the probability will be, that is how we make A and B, because we have to find out PA divided, or not divided, but PA by B. It is the probability of A intersection B divided by number or probability of B. But we know that probability means numbers only. That is why I am writing NA intersection B and NB. So here PA by B, by is not a division, please understand, and B is already known. It is already known. So what is the probability of A when B is known? So PA by B is NA intersection B, NB. You can also write the P also in place of P, because eventually we have to write the numbers only. That is why I have written N. What is A, N intersection B? All the numbers which are common in A and B, these are the A intersection B. So we have 4, 6, 8 is there and 10 is there. So the intersection of event A and B, the numbers are 4. What is NB? Count the numbers in event B, 4 to 10. So 1, 2, 3, 4, 5, 6, 7. These are 7 numbers. So probability of getting an even number from 1 to 10 cards, if it is known that the number on the drawn card is more than 3, is 4 by 7. Now how this will be done? This is how you need to write it and execute it. All these writing, because A and B are very important here. Assume that each born child is equally likely to be a boy or a girl. So it can be a boy, it can be a girl, and the chances are equally likely 50-50%. If the family has 2 children, there is a family, we have 2 children here. So the question being asked is, what is the constitutional probability, that is the conditional probability it should not be a constitutional, there may be a mistake. Given that the conditional probability that both are girls, this is what we have to find out. But it is already given that the youngest girl is a girl, youngest kid is a girl, or at least one is a girl. So we have to have 3 different experiments or events. So this, given that, or if it is known, that means we have to apply the probability which is conditional probability. So A, because I told you we need 3 probabilities. A is there, we call it as an event which is both the child are girls, and this is what we need to find out. Always whatever we need to find out has to be A. Those which are given should be B and C likewise, but what you need to find out should be A. Now what is B? The youngest is a girl. The youngest kid is a girl. I'm writing in short. I'll show you how to write it in just a bit. At least one is a girl. This is our third event. At least one is a girl. Again, writing in shorthand. So what is the sample space? What is the conditional probability that both are girl? So 2 children are there. Like in head and tail, we have HH, TH, HT and TT. Similarly, here we have first and second as boys, because it is equally likely. First can be a boy, second can be a girl. First can be a girl, second can be a boy, or both can be girls, first and second. Now the sample space, the number of elements are 4. So this total is 4. Now coming to A, what is the sample space of A? That is the event A. Both children are girls. So only one G1, G2 is the possibility. So G1, G2. A is this one only. B is the youngest is a girl. Youngest means the second child should be a girl. So this girl 2, wherever we have G2 and in front of that it can be a girl or it can be a boy, but G2 should be, it has to be G2 in the second one. So B1, G2 and G1, G2, that is the youngest is the girl is this criteria. Now making this same for C is at least one is a girl. So only boys you can remove, others are girls. One or the two girls are there. B1 G2, G1 B2 and G1 G2. Now in A, what is n number of elements? A, 1. In NB, we have B1 G2 and G1 G2, that is 2. In NC, we have 3. Now we have to find out different intersection. First, let me write the formula here or the expression here. Given that youngest is a girl, so first we have to find out PA by B and then PA by C. When A, B is given, and what is A when C is given? A by C will come. With whatever thing is given, it has to be in the denominator. Well, it's not a division, just a symbolic way to represent it. So the expression will be like this. P, you can also call it as N because we are going to count the numbers only. NA intersection B divided by NB. NA intersection C divided by NC. So all the numbers I have already computed. So NA intersection B. What is NA intersection B? What is the common of A and B? G1, G2 only. So we are calling it as 1. Now A intersection C. What is common between A and C? Again G1, G2 only. So again NA intersection C will be 1 only. Now let us put it here. NA intersection B is 1. What is the count in B set? It's 2. So 1 divided by 2. Now A and NA intersection C, again 1. What is the count in NC? I just counted it. It's 3. So the probability of both girls, if the given that youngest is a girl, is 1 by 2. And the probability of both the girls, if at least one is a girl, is 1 by 3. This is how you are going to write it. Given that the two numbers appearing on throwing two dice are different, find the probability of the event the sum of numbers on the dice is 4. Now here is a dice. Let me tell you about this. So there are two numbers appearing on throwing two dice. So they are different dice, two dice. So there are 36 combinations that are possible. And we have to find the probability of the event, the sum of numbers on the dice is 4. So we find out the probability, but it is a conditional probability. So we write it like this, PB by A or PA by B. It depends on you, whichever you take. But if A is known, what is the probability of B? This B by A signifies that. If it would have been A by B, then known the probability of B, what is the probability of A? So when you throw two die, this is one die, this is another die. So what is the sample space? It will be 1, 2, like this. 1 and 2. 1 and 1. First one will be 1 and 1. The second will be 1 and 2. Then we have 1 and 3. 1 and 4. 1 and 5. Then 1 and 6. This is the first row. Now the second one will be what? 2 and 1. 2, 2, 2, 3, 2, 4, 2, 5, 2, 6. Like this. So I'm writing 2, 1 and this 2, 2. I hope you got the idea. How about 3? It will be 3, 1, 3, 2, 3, 3, 3, 4, 3, 5, 3, 6. So I'm writing few of all of them. 4, 1, 4, 2, 4, 3, 4, 4, 4, 5, 4, 6. So I'm writing again 2 of them. Then 5, 1, 5, 2, 5, 3, 5, 4, 5, 5, 5, 6. So I'm just writing few of them just to let you understand that how it is going on. The last one will be 6, 6. So 6, 1, 6, 2, 6, 3, 6, 4, 6, 5, 6, 6 like this. Now these are 36. 6 into 6. One die 6, another die 6. 6 into 6 is 36. Now given that the two numbers appearing on throwing two dice are different, that means we cannot take 1, 1, we cannot take 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. That cannot be taken. So all these needs to be excluded because the question is straight away saying, given, it is already given. A is the B by A means A is already given that the dice cannot have similar number. So we have 36 in all. But this 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, 6. So 36 minus 6. I am removing this. So the number of elements in A set is 36 minus 6, which is 30. I hope This 6 I subtracted, you are aware now. All the similar numbers I have deducted. How about B? So the probability of B by A is written as probability of B A intersection B or B intersection A divided by probability of A. Because we are going to use the numbers only, that's why I am using N. Probability is always between 0 and 1. So NA is already 30 with us. How about NA intersection B? So we have to find out the B also. What is the content of set B? So let's see B. And the B set will be the sum of the numbers on the dice is 4. So 1, 3 can be 4. This 1 and 3. All these 4 which you see here, there are 3 4s here. So 1, 3, 2, 2 and 3, 1. Like this. So 1, 3, 2, 2, 3, 1. Now in the question it is given that this similar number cannot come. So we have to eliminate this 2, 2 from here. So how many now elements are left here? 1, 3 and 3, 1. That is only 2. So the number of elements in B is 2. So now we have number of elements in A in B. But we need to find out A intersection B. What are the common elements of A and B? So we have 1, 3 and 3, 1. So I'm writing 3, 1 also, which I just skipped. So 1, 3 and 3, 1. So the NA intersection B, because probability is all about the number of elements in that set. So only 1, 3 and 3, 1 are common in A and B. So there are 2 numbers, 2 values. NA intersection B is 2 and NA is what? So NA intersection B is 2. Number of elements in A, as I suggested you, it's 30, not 36. It will be 1 by 15. So whatever I told you is in front of you. This is how you're going to go about it. You have to form this A and B. You can change this A and B by yourself. It can be written as P by B by A or PA by B, depending upon what you have chosen A and B. All the sample set of A or sample space of A has to be made. And I have rejected this 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6 that you don't see here also. And B is the sum of numbers on the 2 die is 4. That is 1, 3, 3, 1, 2, 2. And you have to eliminate 2, 2 also. So now apply the formula, 1 by 15 will come. A coin is tossed 3 times. So there is only one coin. There are not 2 coins. Okay, there is only one coin. If head occurs on the first 2 cases, find the probability of getting head on the third toss. This is a conditional probability. If head occurs, if it is already given that, if it is known, all these kind of phrases will tell you that this is a conditional probability question. So let's take A as getting head on third toss. Find the probability of getting head on the third toss. So we have taken A as getting head on the third toss. And if it is already given, and it is given if head occurs on first 2 tosses. So we'll take the set B as getting head on first 2 tosses. Now what is A now? Getting head on third toss. So this is very clear for A that the third will always be a head. So let's make it like this. The last one will always be head. Head, 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 head. Why am I writing 4 H's? Because in previous 2 either head or tail will come. And head and tail can make 4 combinations. Head, tail, tail, head, head, head and tail, head. So the A will be H, H, H. I'm writing in a different way now. Then the second one will be H, T, H. So third toss H we have fixed, and now we are writing the combination of H and T, that is the permutation and combination of this permutation of H and T. So T, H, H and then T, T, H. First 2 can come anything, the last one has to be H. So A is done now. Coming to B, getting head on first 2 tosses. So we have to fix H, H now. H, 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 H. So only T can come and H can come because we have fixed the first 2. Third can only be tail or a head. So let me write B now. H, H, H and H, H, T. H, H, H and H, H, T. So what is the number of elements in A? We don't have to get NA and NB always. Only one of them we have to know. But it's good to know the values. So 4 in A, 2 in B. And A intersection B, what is the common element in these 2 set? Only H, H, H is there. Only this one and this one. So only one is common. So NA intersection B will be 1. Now we have to find out the probability of PA by B. That is, if B is known, if getting head on first 2 tosses is known, what is the probability of getting head on the third toss? That is how conditional probability is approached. So PA intersection B divided by PB, and this is only N only. Number of elements we have to count. And N intersection B and N B. N intersection B is 1. And B is 2, so 1 by 2. This is your final result. Now this is how you are going to write. I have explained you in detail, but this is the approach you are going to follow. This is a conditional probability question. You have to be aware of PA by B or PB by A. Whichever you choose as A and B, it depends on you. A die is thrown 3 times. Find the probability that 4 appears on the third toss if it is given that 6 and 5 appear respectively on first 2 tosses. So let me just show you the die. But there is only one die which is thrown 3 times. There is no 2 die, or there are not dice, only die. Now if it is given, this is already given, normally we take what is given as B, and we normally take A as what is to be found out. This is what the tradition is. PA by B is PA intersection B divided by PB. So number of element of A intersection B divided by number of element in B. So NA will not come here. So you don't have to count the, or don't have to make the A set. You just have to find out B and A intersection B. But for that you have to have a set A. Always find is, whichever you have to find out is find, which is taken as A. So getting 4 on the third toss will be taken as A. And B will be what? B will be getting 6 and 5 appear respectively on first and 2 tosses. So first 6 will come, followed by 5. So our die will face up 6 first, and then the second time it will be 5. Now let me write the B set. You know why? Because A will be a humongous set, but by B we can restrict A. 6, 5. 6, 5 will eventually come, but the third will be, it's not known. So 6, 5 will come. So I'm writing 6, 5, 6, 5 6 times. You know why? Because every dice can give us 1 to 6 number, but the 2 are fixed here, 6 and 5. So 6, 5, I'm writing 6 times now. So 6, 5 again. But the third toss or third die can give you 1 to 6 number. That's why I'm writing 1, 2, 3, 4, 5 and 6 here. So B set is fixed now. Let's make A now. Getting 4 on third throw. Now here the last one is fixed. So last one is fixed. 4, 1, 1 can come. Now 1, 2 can come. 1, 3 can come. 1, 4 can come. But the last one is fixed. So let me write just to let you know. So just fix the last one. So I'm fixing the last one here. 1, 1, 1, 2, then 1, 3, then 1, 4, then 1, 5, 1, 6 like this. Now the idea is, why to write all these? Because NA is not to be known. We don't have to write all the members because we don't need to calculate the number of elements in this set. But we know that there will be an intersection because there has to be something common between A and B. But the intersection will be only from where this set will start with 6. So 1, 1, 4, 1, 2, 4, 1, 3, 4, 1, 4, 4 can never give you any intersection. Only the last, that is 2, 1, 4, 2, 2, 4, 2, 3, 4, 2, 4, 4, 2, 5, 4, 2, 6, 4, all this will come. But we don't have to worry about that. Again 3, 1, 4 till 3, 6, 4 will come. Then 4, 1 to 4, 6, that is 4, 1, 4 and 4, 6, 4 will come. 5 and 4 and 5, 6, 4, that will also come. But we don't need it. Only the intersection will be from the last one, last row. In 6, 4 is fixed. Let me write 4 again 6 times. So I'm writing 4 6 times. Now first can be 6 1, first and second can be 6 1, then 6 2, then 6 3, then 6 4, then 6 5, then 6 6, like this. Now you tell me whether it was required to write from 1 1 4 to say 5 6 4. We don't need them. If you take the intersection of A and B, only anything 6 5 4, they see this will never be intersected. Only 6 5 4 is the value which is common in A and B. So the intersection of A and B will only give you one element. So NA intersection B is only one, and with the content is 6 5 4. That is the only commonality between these two. What is NB? 1 2 3 4 5 6. So we have 6 in NB, that is number of elements. This is 1 by 6. So this is how you're going to write and go about it. I hope you have a better idea now. See, here also we haven't written, we have just started, but we have come down to 6 2 4, 6 1 4 till 6 6 4, because it is going to eventually be intersected with B, and B has only 6 5 4 and A has only 6 5 4, which is common. That is the one element in A intersection B. And whole B is of course 6 numbers, 6 values inside the set B. Now compute PA by B if PB equals 0.5 and PA intersection B is 0.32. Now let me tell you the formula first. This is PA by B. It is not divide. If you know the probability of B, what is the probability of A? Is PA by B. This is a conditional probability. So in the numerator, it will always be the intersection of these two sets. That is, if you take intersection of A with B or B with A, it remains the same. In the denominator, it will be always the denominator, that is PA by B, so PB will come. This B, which is below, will always come in the denominator. So they are basically the numbers NA intersection B divided by NB. What is PB here? It's given already 0.5. PA intersection B is also given, which is 0.32. So PA by B will be computed like this. So this will come as 32 divided by 50, and this will be 16 divided by 25. Now please remember that you need to check that the probability has to be between 0 and 1, inclusive of 0 and 1. So 16 by 25 is indeed between 0 and 1 and equivalent to 0 and 1, that is, it lies between these two peripheries. Now this is the formula. Now the next question is PA, PB, PB by A. We have to find PA intersection B and PA by B. I'm not saying PA divided by B or PB divided by A. So this, let's write this formula first. PB by A, that is the probability of A is known, and we need to find the probability of B according to it. This will be, A comes in the denominator, PA, numerator will be P, A intersection B or B intersection A, it remains the same, so we'll write always PA intersection B in the numerator. PA intersection B, this is what we need to find out here. PA is already known to us, that is 0.4, PB by A is also given in the question, which is 0.5. So let's write it here. Multiply these two, PA intersection B, and this will be 0.5 into 0.4, that is 0.2. Now the second one which is wanted in this question is PA by B, that is, if B probability is known, what is the probability of A? That will again be PA intersection B, and this will come in the denominator PB. So what all we have? PA intersection B, which is 0.2, PB is 0.3, and this is PA by B. So 0.2 by 0.3 is 2 by 3. So this 2 by 3 will be your probability of A when B is known. That's your answer. So two of the things we have found out. So this is how this will be done. This is the formal way you have to go about in order to solve this. Now in this question, A and B are two events such that PA, the probability of A event is 1 by 3, probability of B event is 1 by 5, and PA union B is 11 by 30. So we have to find out the probability of B if A is known, B if A is known. So A union B, this formula is very important. PA union B is PA plus PB minus PA intersection B. So PA union B is already known, 11 by 30, PA is 1 by 3, PB is 1 by 5, and PA intersection B has to be computed. So PA intersection B will be what? PA intersection B is 1 by 3 plus 1 by 5 minus 11 by 30. So this is very basic mathematics. Let me write the final result of this one, 1 by 6. I hope you'll be able to do this. Now PA by B and PB by A, let's write them together so that you understand that the formulas, how they are being made here. PA intersection B remains in the numerator for both the cases. So PA intersection B in the numerator. The denominator will take the probability of what is known. So PB which is known in this case, and PA in this case. What is PA intersection B? We just found out to be 1 by 6. So let us write it. In the second part also I'm writing the first numerator. How about the denominator? It's given in the question. PB is given in the question, which is 1 by 5. PA is given in the question, which is 1 by 3. Now let's solve it. The denominator of the denominator will go as the numerator. So 5 by 6. Again, this 3 by 6. This will be 1 by 2. So 5 by 6 and 1 by 2 are the result of these questions. Now you need to check that these probabilities lie between 0 and 1, inclusive of 0 and 1. So this is your final result. And this is the final result. This is how you have to go about it. A couple has two children. That is, this is the first one, this is the second one. You can call them as mother and father. Now they have two children. This is the first one, this is the another one. Now they are different permutation which are possible. First of all, find the probability that both the children are males. We have to find the probability that both the children are males and both the children are female when the condition is given in the first case is if it is known that at least one of the children is male. The second one is both the children are females if it is known that the elder child is female. So when the question comes like this, if it is known, given that, all this demands the conditional probability. The conditional probability has to be there. So for that we have to make you already know that we may have to make a sample space of all the possibilities. Then we make the different sets for all the possibilities pertaining to the question being asked. See, the sample space will always be made. So the first kid can be male, the second can also be a male. Both are males. The first can be male, another one can be a female. The first one can be a female, the other one can be a male. Both kids or children can be female. So if you have two, say, different things, the possibilities can be 2 by 2, that is 4. That's what I'm writing, M1, M2, M1, F2, that is male, 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 female, female, male, and female, female. So this is the bigger set or the whole possible set. Now pertaining to this question, particular question. So first is A. Both the children are female. This is the set. You will wonder why I'm taking A as both children are female. Why I'm not starting with the probability that both the children are males. You'll just see now. A is both the children are female. That is F1, F2. That is the content of this set. Another B, which is the event, is the elder child is a female. So I'm taking according to the question or the answer I perceive. That's why I'm making it like this. B is elder child is a female. Now see here, elder child means the first child should be a female. The other child doesn't matter. So F1, F1, wherever you have the first child as female, the next one can be anything. So F1, M2 and F1, F2 will come. So F1, M2 and F1, F2. This is your B. The next will be set C. At least one of the children is male. So in the sample space, you have to find out that at least one has to be M. Both can also be M. So I'm writing at least one child is male. So you just can't have female, both the females cannot be there. Other all possible combinations or other, say, elements of the event are possible. That is M1, F2, that is one male here, F1, M2, again one male here, and M1, M2, that is both are males here. Then coming to the set D. Both children are males, and then same as both children are female, there is only one element of this set is possible, F1, F2. Similarly, both children are males, that is M1 and M2. This is the only possibility. We cannot have a female in between. Or first or second can be female, both can be female. That is not possible in this case. Now as we have made all these sets, let's come to the question being asked. The first one is, find the probability that both the children are males if it is known that at least one of the children is male. Now what is D and what is C? C is at least one child is a male. That is why we have taken this. So if C is known, that is at least one of the children is male is known, what is the probability of both the children are males? So the first one is P D by C. C is known. If it is known that at least one child is male, what is the probability of D, which is both children are males? This will be P D intersection C divided by P C, and this probability is simply N, the number of elements in this. So D intersection C. So what is the common between D and C? You have already the element, just see which one is common, which is the intersection. So M1, M2 is the only element which is common in both these sets. What is the number of element in D intersection C? M1, M2, that is 1. So P D intersection C is 1. So eventually you have to write the number. So it will be 1. What is C? PC. That is probability of C, number of element in C, which is 3 here. M1, F2, F1, M2 and M1, M2. 1 by 3. Now coming to the second one, which is the probability of A by B. Now if we know that the child is female, find the probability that both are females. That is, you have made the set like this. So PA by B is PA intersection B divided by PB. PA intersection B is what? NA intersection B divided by NB. So what is NA intersection B? Take A and B, find the common values, common elements. F1, F2 is the only common element. So NA intersection B is 1. What is NB? How many elements are there in B? F1, M2 and F1, F2. That is 2. So we have 1 divided by, this is 1 divided by 2. That's your final result. 1 by 3 and 1 by 2. Now this is the whole procedure. It was a good question. You may be able to do it by yourself. So this is all about this exercise. Thank you so much. Have a good one.